Welcome to our presentation on the Cycles Protocol, an innovative peer-to-peer electronic clearing system. This protocol is designed to address the liquidity challenges faced by financial institutions and offer an open, decentralized solution for clearing, settlement, and issuance. For centuries, financial institutions have faced liquidity challenges, often resulting in gridlock and insolvency, particularly affecting small enterprises. Blockchain technology has enabled open, decentralized systems, yet these solutions have primarily been used for speculative purposes. The Cycles protocol aims to overcome these challenges by enabling firms to clear more debt with less money through a privacy-preserving, multilateral settlement platform. Financial inequality, especially among small enterprises, is exacerbated by the stringent requirements of traditional clearing systems. Advances in privacy-preserving technology and graph algorithms allow for more inclusive and efficient debt clearing mechanisms. The Cycles protocol leverages these advancements to optimize debt settlements and improve liquidity. Payment systems consist of obligations and liquidity sources. Existing systems focus on asset transfer and exchange with limited support for obligations. Our design aims to enhance and complement these systems by focusing on reducing debt with minimal liquidity, leveraging a network structure of obligations. The Cycles protocol introduces a universal language for representing financial relationships and optimizing them through graph algorithms. The system of intents allows participants to express and settle their debts efficiently, leveraging various liquidity sources. Our system is built on key intent types: obligations and acceptances, with settlement records denoting the extent of settlement. These components enable programmable payment transactions, facilitating a wide variety of payment, currency, and credit protocols. Obligations represent any payment, such as debts or invoices, while acceptances define how these obligations are to be paid. The settlement of acceptances creates opposing obligations, forming cycles in the payment network. This graph representation helps optimize the clearing of debts, leveraging various liquidity sources. Tenders are a way of settling debts or obligations. For instance, if Alice owes Bob $30, she can use various assets like bank deposits, stablecoins, or even Bitcoin to settle the debt. The tender specifies how Alice intends to discharge her obligation to Bob. A tender can be bank deposits, stablecoins, or cryptocurrencies, and it sets the terms for settling debts. Settlement records are generated from the application of settlement flows to obligations and acceptances. They indicate how much of each obligation or acceptance is to be discharged. These records are essential for ensuring that payments are balanced, with each transaction being cyclic. They can be executed on-chain or off-chain, depending on the type of assets involved. There are 4 primary methods for settling debts: set-off, assignment, overdraft, and assumption. These methods correspond to different ways of adjusting the balances and liabilities on the balance sheets of the involved parties. Set-off allows for the discharge of obligations without the transfer of money, while assignment transfers assets to discharge obligations. Overdraft involves borrowing to pay, and assumption involves transferring liability. Set-off is a method of discharging obligations by balancing them against each other. For example, if Alice owes Bob, Bob owes Carol, and Carol owes Alice, they can all offset their obligations. This reduces the total debt in the system, as shown in the graphical representation. The balance sheets for each party show the reduction in liabilities and assets after set-off. Assignment involves discharging an obligation by transferring assets. This method can be initiated unilaterally by the debtor and allows for multiple consecutive assignments to discharge multiple obligations. The chain of assignments shows how the same money can be used to clear a series of debts, reducing the balance sheet of the debtor. Multilateral settlement combines a single assignment with multiple set-offs. For example, Alice's money can be assigned to Carol, and all intermediate debts are set off. This method avoids creating new relationships between parties and allows for an efficient clearing of debts using a liquidity source like USDC or BTC. Overdraft involves discharging one obligation by creating a new one, essentially borrowing to pay. For example, a bank can provide an overdraft facility to Alice, allowing her to pay Bob while creating a new liability to the bank. This method increases the bank's balance sheet but does not change Alice's or Bob's balance sheets. In expanding a bank's balance sheet, New money is created via issuance. This occurs when banks extend credit, creating new deposits without using existing money. Overdraft facilities are used for payments, reducing debt without acquiring new assets. The bank's liabilities are accepted as money, meaning the same node can serve as both the overdraft facility and the liquidity source. Alice might prefer borrowing from a local lender rather than a bank, and Bob might not want to hold the money. In multilateral settlements, any lender can provide a credit line via an overdraft facility. When overdraft and liquidity nodes are separate, we refer to this as overdraft without issuance, expanding the overall balance sheet. Factoring involves Alice owing Frank instead of Bob, with Frank buying receivables at a discount. Overdraft allows Alice to borrow from Fiona instead of being forced by Bob. P2P loans enable Alice to borrow directly from Carol. This flexibility empowers debtors with more control over their credit sources. Graph-solving algorithms identify cycles that clear debts efficiently. The MTCS algorithm finds minimal cost paths, ensuring all obligations and cycles are cleared. Even small amounts of liquidity can clear larger debts due to the multiplier effect. Introducing multiple liquidity sources enhances the network's efficiency. Each currency operates in separate circuits, eliminating the need for currency exchange services. Firms benefit from set-offs in separate cycles, improving overall liquidity flow. We turn our attention to the Cycles protocol, which shifts focus from payment system design to protocol design. We begin with a problem statement and user flows, then delve into the base privacy and settlement architecture, and finally discuss design choices and extensibility. The Cycles design requires executing atomic multilateral settlement operations in a privacy-preserving and extensible credit environment across multi-scale graphs. Atomic multilateral settlement means operations need to happen simultaneously among many participants. Privacy ensures these operations are kept confidential. Extensibility allows integrating various liquidity sources and credit rules. Assignment tenders involve paying debts using stablecoin balances on Cycles. Overdraft tenders allow users to draw stablecoins using other assets as collateral. Issuance refers to creating new assets within the protocol. External DeFi integrations enable borrowing from external protocols and integrating those assets into Cycles. The architecture uses TE and ZK proofs for privacy. Users encrypt their intents and submit them to the chain. The TE decrypts these intents and computes the settlement. The results include set-offs and balance changes, which are re-encrypted and published alongside ZK proofs for verification. ZK proofs validate that only balance flows are applied and no user intents are violated. The proofs include steps for decryption, ensuring each obligation has valid signatures, and using Merkle trees to manage large proofs. The extended architecture includes encrypted intents and set-offs, interchain communication, and the use of Cosmos blockchain for reliability and interoperability. This setup allows Cycles to integrate with external assets and credit facilities effectively. Today, we'll delve into Cycles, a blockchain-based system, and explore its integration within the Cosmos ecosystem, its unique features, and economic implications. Cycles uses interblockchain communication, IBC, to draw in liquidity from various Cosmos assets. It also leverages credits from Ethereum, creating a robust source of permissionless lending protocols. Smart contracts and Cycles can participate directly in the obligation graph, enabling efficient creation and management of assets and credit facilities. Privacy is maintained through native architecture and zero-knowledge proofs, ZKPs. Each account within Cycles acts as an independent lending protocol. This allows the system to focus on repayment acceptances, integrating new credit protocols, and optimizing liquidity injection. Overdraft facilities and Cycles allow users to manage obligations through standing tenders and acceptances. Decentralized exchange systems can be strategically incorporated to optimize liquidity flows. Cycles' core insight is its extensibility, allowing for diverse credit sources. This enables the system to function effectively in a risk-reducing environment, providing a preferred platform for lending and borrowing. Cycles helps reduce payment gridlocks and systemic risk, offering firms a comprehensive treasury dashboard. This functionality, usually reserved for large financial institutions, is made accessible for all users. In conclusion, we introduce Cycles, an open clearing and issuance protocol. Its graph-theoretic design minimizes debt with the least liquidity, providing a compelling use case for blockchain in managing working capital concerns.